Hello everyone. So guys, I'm Rahul Kaushik and I welcome you all on Unacademy JEE English channel guys. Yes, JEE English. This is the channel guys. And on this channel guys, each and every concept of ITJ will be taught you in pure English. And I'm Rahul Kaushik. Today I'm going to take on session on degree of dissociation. Guys, today we will discuss degree of dissociation lecture number 5, chemical equilibrium. So, first of all, before we start today's session, guys, let me tell you something about myself. I'm Rahul Kaushik, guys, and I worked in Bansa Classes Kota since 2010 to 2020. So, guys, continuous 10 years I worked there. And during my tenure there, I was head of department, guys, and I mentored 2000 plus IITs. I mentored 2000 plus IITs. Hello, Madhvi. Good afternoon, Madhvi. And after that, guys, I co-founded my own organization that is Zigyan Education Private Limited. Now, along with Zigyan, I'm here on Unacademy, India's largest and fastest growing online platform. So, guys, we are there on the Telegram app as well. And name of our Telegram channel is JE underscore English. And link for this channel is given in the description part of this video. Okay, guys. So now I will tell you some simple steps how you can subscribe to Unacademy, guys. So step number one, just go to Play Store or App Store, download Unacademy's learning app. Once you are downloading it, guys, install it. And after installing it, you will be directed onto this page. And on this page, you have to click on the plus. Once you are clicking on the plus, you will be getting these options. So choose IIT. And once you are choosing IIT, then hit the subscription button. And after hitting the subscription button, guys, after hitting the subscription button, you will be directed to this page. And Rahul Cam, guys, this is my code Rahul Cam and very important for you. Now let me tell you guys, without this code for 1 year you have to pay 38,000, for 2 year you have to pay 56,000. But I'm telling you guys, if you are applying this code Rahul Cam for chemistry and Rahul my name, guys, if you are applying this code Rahul Cam, then you will be getting, you have to pay 34,000 for 1 year and 50,000 for 2 year. This would be the fee structure, guys. And along with this fee structure, I'm also telling you one more point. What are the, you might think, what are the advantages of taking plus or subscription, guys? So I'm telling you, on YouTube we are just delivering you the lectures, you can download the lecture notes, but on the plus the course is structured. The course is structured like like after every class you will be having doubt clearing session. Every fourth class will be doubt clearing session, and then along with that class during session, guys, there are live quizzes. Every week you will be having live quizzes, and once your topic is over, then you will have mega quiz. So live quizzes will be there, mega quizzes will be there. And after that, guys, the most important thing, yes, you will be part of an academy's test series, guys. And test series is very important because once you are part of any test series, and a test series in which large number of students are there, that is going to help you immensely. That is going to help you immensely. So I'm telling you guys, these are all the benefits. These are all the benefits. And other than this, one more point I missed, that is, you will have access to not just my video lecture and content, but the video lecture and content of all the educators who are teaching over there. Okay, guys. So now I'm going to start chemical equilibrium degree of dissociation. So first of all, I will discuss what do you mean by degree and what is dissociation. So first I will break up this term and I will explain you what is the meaning of degree of dissociation, and then we will move how to calculate degree of dissociation, what are its advantage, what is vapor density, and why we are calculating degree of dissociation. Is there any specific reason behind it? So these are all the questions which might be, yes, which might be in your mind currently, and I will try to answer all these questions, guys. Okay, any doubt, guys, please ask. Any doubt? No doubt. So now, guys, let's move now. So I'm moving I'm moving to the next point, degree of dissociation. So first of all, what do you mean by degree? Degree, it is not the degree which you get after completing 4 years of BTech degree or MTech degree. No, it's not like that. This degree means extent, means up to which extent, up to which degree. So this is that kind of degree. This is not the degree BTech or MTech. Okay. When we are saying degree of dissociation, so this is guys, this is extent, and if this is extent guys, dissociation means, what do you mean by dissociation? So dissociation means something that is big is being dissociated into smaller atoms or molecules or ions. So hi Osho, so what will happen? Suppose I am taking CaCO3 solid and it is dissociating into CaO solid and CO2. So we call it we call it dissociation, right? Why dissociation? Because a large or a big molecule is being dissociated into smaller ones, right? So degree means extent. तो किस extent तक ये dissociate होगा? Madhvi, actually I don't have idea about this. Yes, Osho is telling you there is iconic. Yes, there is some iconic test series, right? So when I'm talking about degree, degree means extent. Suppose you have taken 100 more. Initially it was 0, it was 0. And after some times, what happens? Suppose 40 moles reacted. So this will be 40, this will be 40, and 60 mole will be left, guys. So out of 100, 40 mole or 40% has been dissociated. So I will say this is suppose I am taking A. This is suppose I am taking A, and I generally denote it by alpha. So alpha, what do you mean by alpha? So degree of dissociation is defined as the extent or the fraction. So it is the fraction to which a molecule is dissociated. Suppose your fraction is 0.4, 40% of the amount is dissociated. So how will I write it if this is A? So I can write it like A00, and how much amount has been dissociated? Hi Dr. Arsineshwa. Hi Dr. Arsineshwa. Yes. So amount dissociated will be A alpha. So what will be the amount left? A minus A alpha. This is at 0 and this is after time t when equilibrium has been achieved. So it will be A alpha and A alpha. Now I hope you are getting this alpha. I say it is degree of dissociation. Here you can write it if alpha is 0.4. So 40% percentage is calculated over 100 and fraction is calculated over 1. Got it, guys? Tell me. Any doubt? So here you can say A minus A alpha. So guys, note it down. Degree of dissociation is defined only for single reactant. Degree of dissociations. Hi Ravi Shivaradi. Hello. Degree of dissociation is defined only for single reactant. Yes. Note it down, guys. Degree of dissociation is defined only for single reactant, because single reactant will dissociate into smaller one. If there are more than one reactants, then we will not call it degree of dissociation. So what do you mean by dissociation? So guys, dissociation means a big molecule is breaking down into smaller ones. Okay, Ravish, Dr. Archin, Yashwa, Madhvi, any doubt? Please ask me if you have any doubt. Tell me if you have any doubt, guys. So note it down and just note down one more point. Just note down one more point. That point is all dissociation reactions are all dissociation reactions are endothermic. So what do you mean by endothermic? Endothermic means they require some heat. They require some heat. Yes, guys. So write down some expressions for it. Now I'm giving you. Suppose I am writing A gas, giving you B gas, 2C gas, and at T is equal to 0, you have A mole of it and degree of dissociation is alpha. So write down the expression for it, guys. Write down the expression. Yes, everyone, I'm waiting. So what will happen? 0 and 0. A minus A alpha, 2A alpha. So this is the expression, guys. So just visualize it. And what do you mean by when I'm saying visualize it? Initially, there were A mole of A mole. But once the equilibrium has been established, then you will have A, B as well as C. And moles of A will be A into 1 minus alpha, B will be A alpha, C will be 2 alpha. Now you have moles of each and every reactant and product. Okay, guys. Now you will have any doubt, please ask me. Got it? So why I'm telling you this is A alpha, 2A alpha. So initially there was only one gas. Now there is a mixture of gas. And if there is a mixture of gas, in that case you can determine the average molar mass of mixture or you can determine the vapor density. That is important. You can determine the average molar mass of mixture or you can determine the vapor density. I will discuss that as well. Don't worry. But before that, let's do some practice. Now if I'm giving you A gas and it will give you 2B gas, 3C gas at T is equal to 0. Suppose I'm saying this is degree of dissociation is alpha and it will be A. This is 0, this is 0. Yes, definitely, but I will teach pH only about pH when we will reach there. Currently, we are not in a position. In ionic equilibrium, we will discuss each and everything about the pH. That class will be purely based on pH. Yes, Triveni. So now just write down the expression for it as well. Write it down, guys. What will be the expression here? The expression will be A minus A alpha, 2A alpha, 3A alpha. So if I ask you the total mole, guys, here the total mole in this case will be, just add them, cancel them, you will be getting 1 plus 2 alpha. These are the total moles for it. And in this case, so on adding you will be getting a 1 plus 4 alpha. So these are the total moles. I hope now you are getting it. I hope now you are getting it. Okay. So let me take one more example here. 2A gas, 3B plus C. Suppose at T is equal to 0, A mole and degree of dissociation is alpha. So just write down the expression for it. Write it down, guys. Let's see how many of you can write the proper expression for it. Do it. Yes, are you done with it, guys? So how will you write it? Here we are having 2. So many of you will write A minus 2A alpha, A alpha and A alpha. And students, I'm telling you guys, this is wrong. This is wrong. Why this is wrong? Now I will explain this. Suppose initially you took 100 mole, suppose, and your alpha is 0.2. It means out of 100, 20% A will dissociate. It means out of 100, 20% will dissociate. So 100 minus 20 should be there. But if you are writing 100, 2 into 100 into 0.2, it will be 100 minus 40. So this is the point of error, guys. This should be 20 here because alpha is 0.2. So out of 100 mole, 20% of the mole should be dissociated. So many of you will commit this error, guys. Many of you will commit this error. So avoid it. So in such a scenario, when this coefficient is 2, 3, 4 or anything else, so in that case, how you have to do it? A00, and it will be, again you will just write, always write A alpha. So it will be 3 A alpha by 2 and it will be A alpha by 2. So always write A alpha, never write 2 A alpha. Otherwise, instead of 20 mole, 40 will be reacting, and that is wrong. That is wrong, guys. And if that is wrong, so what should you do now? What should you do? Here, if you write it 100, so it will be 100 minus 100 into 0.2. It will be 100 minus 20. So 20 moles are reacting. Got it? Yes, tell me. Any doubt? No doubt now? No doubt? So this is A minus A alpha, this is 3 alpha by 2, this is this. I hope now you got it. So before I proceed ahead, guys, let me take one more problem. 3A gas, 4C. Yes, write it down. So what will you write here? Again, you are having coefficient 3. So you will write like this way. A minus A alpha. Don't write A minus 3 alpha. I told you what is the problem with that. And after that, it will be 2A alpha by 3. Okay, I will upload it. I will upload it. And after this, you will be getting 4A alpha by 3. Are you getting it, guys? So what will be the end total here? Just add it. Just get it. So why every time I'm doing it? Why every time I'm telling you? So guys, the next point is vapor density. Next point is vapor density. And how you are going to calculate the vapor density. So let's take one example for it. So note it down. The vapor density, and average molar mass, mm. So guys, you know that vapor density will be average molar mass of mixture divided by 2. And what do you mean by average molar mass of mixture? So now I will discuss. Suppose in a container initially you have taken PCl5 gas, right? Once you have taken the PCl5 gas, now this PCl5 gas dissociates, and if it dissociates into PCl3 gas plus Cl2 gas, so what will happen? Suppose at T is equal to 0, A moles of this were present, and after some time A minus A alpha, it will be A alpha, it will be A alpha. So this is the time when equilibrium has been achieved, because at this point, if n number of moles of BCl5 are going forward, suppose zero point 0.1 mole is going forward, so zero point 0.1 mole will come backward. As a result, its concentration or its mole will become constant. So what will happen here? What will happen here, guys? So I'm telling you, in this case, when equilibrium has been achieved, you will be having BCl5 gas, BCl3 gas, Cl2 gas. So once you are having these three, so you will be having A minus A alpha, A alpha and A alpha. Got it? So if you are getting A minus A alpha, A alpha and A alpha, so all three gases are there, BCl5, BCl3 and chlorine. Okay. So in this case, initially there was only one gas and a mole of it were present, and molar mass of it is 208.5 gram per mole, suppose. So guys, during a chemical reaction, total mass will not change, but total moles will change. And in case if you add them, the total mole you will be getting 1 plus alpha. So now if somebody asks you calculate the average molar mass, what will you do? So M average will be equal to weight total upon N total. So what is weight total here? What is weight total here? So if you are taking a mole of it, A into 208.5, because a mole I have taken, and finally there will be same mass which was initially present. Now total moles have been changed, A into 1 plus alpha. So A will get cancelled out. If alpha is given, guys, you can determine M average here. And if it is not given, if M average is given, then you can determine alpha. So this 208, technically we call it theoretical molar mass. Theoretical means when you have assumed there is no dissociation. When you have assumed, guys, there is no dissociation. So this is theoretical molar mass. So now you know about the theoretical molar mass, guys. So we can also write it as A into theoretical molar mass, and it will be 1 plus alpha. It will be 1 plus alpha. This is average molar mass. So A will get cancelled out. So 1 plus alpha will be M theoretical over M average. So what will be the theoretical molar mass? I told you 2 into Weber density will give you average molar mass. So 2 into theoretical Weber density, or 2 into average vapor density or actual vapor density. Not average, I should call it actual vapor density. Cancel it, and from here you can get alpha. Vapor density theoretical, vapor density actual, minus 1. Any doubt, guys? Any doubt? So you can do anything. You can find M average, you can find average vapor density or actual vapor density, anything you want. Anything you want. So are you getting what I'm saying now? Tell me, are you getting it now? So let's move ahead, guys. Let's move ahead. So now you are comfortable with theoretical molar mass or vapor density. So now for association, what will you do? So just like degree of dissociation, we have degree of association. And what is associating? Like I'm taking 2 chloride and it is converting into Cl2. So I will take a general expression like Na going into An. So T is equal to 0 if A moles of it are present. This is alpha. Then after some time, A alpha by N. Okay, guys. So what will be the total moles here? It will be A into 1 minus alpha plus alpha by N. You will be getting it. You will be getting it. And if somebody asks you what is alpha, So here alpha I will call it as degree of association, degree of association, right? Hi Priya Bajaj. So after so many days, so now I am giving you one question, guys. Solve it and be fast. Let's see who solve it fastest. Calculate average molar mass and vapor density of mixture if NH3 means ammonia. If NH3, yes, Kavya, we take. Okay, you are also not feeling well. Kavya, I take daily classes, and one day I take classes for 11th MWF, Monday, Wednesday, Friday, and on Tuesday, Thursday, and Saturday we take classes for 12th. So classes are every day, guys. Okay, Kavya. So here mixture if NH3 dissociates by 20%. Okay, Priya. So do you have high fever even now, or are you okay? Because if you are not feeling well, then you should not watch this lecture. It will affect your eyes. So now solve it, guys. Solve it. Calculate average molar mass and vapor density of mixture if NH3 dissociates by 20%. And initially assume that only ammonia was present. Assume that. Fast. Okay. So now solve it. Yes, Kavya, Priya, Triveni, everyone. Solve it now. Solve it. So now I will start it. So just write this reaction NH3 gas. It is dissociating into half N2 gas, and it will be 3 by 2 H2 gas. On Sunday we don't have any classes. Generally we take sessions on motivational session on how to study. Yes, Kavya, you might have seen yesterday's class. It was all about how to prepare for 2022. And the day before yesterday I was telling the same thing but for 21 guys. So on Saturday and Sunday, not every Saturday, but generally on Saturdays or Sundays, we take these motivational sessions so that we can interact with you, because just studying is not sufficient. You have to be systematic, and once you are doing it systematically, only then you will be able to get good ranks. Okay? Yes, Kavya, now solve it. Now solve it fast. So NH3 gas getting converted into N2 gas and 3 by 2 H2 gas. Now what will happen here? Okay, Kavya, for droppers, I'm going to start a compact series in which I will cover complete physical and inorganic, and I will take daily classes for that. Don't worry about it. Okay. Yes, I already know about droppers feeling. So very soon I will be launching a course. Very soon. Yes, in which I will take complete theory, DPPs, everything will be there. Right? So now solve this question. Solve it. So if I'm taking initially, suppose I'm taking a mole of it. This is 0, this is 0. Yes, for droppers. That course will be purely for droppers. Okay, we have to understand feeling of all students, so don't worry. Everything would be covered here. So after time t, it will be a minus a alpha by 2 and 3 alpha by 2. So initially, you can assume it like you have taken ammonia and a mole of it were present. And once your equilibrium was achieved, so you will have ammonia, nitrogen and hydrogen. So moles of ammonia are a minus a alpha by 2 and 3 alpha by 2. So what will you get now? So what is M average? M average will be weight total upon N total. So weight total, whatever was the initial weight, same mass will be there because during a chemical reaction, total mass remain conserved. So if total mass is conserved, you will write A into 17 and N total, just write it down in total. And once you are adding it, you will be getting 1 A into 1 plus L. Cancel it. Now it says alpha is 0.2, 20%. So percentage is given, but you need fraction. So M average you know now. M average you know. So how will you determine the vapor density? It will be equal to M average by 2. So you know M average as well as vapor density. So now I am giving you the reverse problem. Let me check how many of you can solve it now. Let me check. If initially only N2O4 gas was present and it dissociates into NO2 and at equilibrium vapor density found was 30. So when equilibrium was achieved, vapor density was 30. Initially only N2O4 was present. So guys, find degree of dissociation. And what is the reaction? Yes. Now do it. Let's see how many of you can solve it. Let's see it. Do it fast. Do it fast. Do it, guys. Initially only N2O4 was present. So suppose initially a mole of it were present in the container, a mole. And once your equilibrium has been achieved, you will be getting N2O4 and NO2. So how many moles of it are present now? A mole of it and A minus A alpha, because once you are writing it, it will be A minus A alpha and it will be 2A alpha. So it will be 2A alpha. So these are the total moles now, and in total will be just add them, it will be A into 1 plus alpha. And if it is A into 1 plus alpha, so what will be M average here? It will be V total upon N total. So guys, do it now. Do it fast. Do it fast. Yes, I'm waiting. Be fast. So when you will be writing weight total, what you will be getting here? A into 92. And what about N total? A into 1 plus alpha. A will get cancelled out. Now what is M average? It will be 2 into vapor density. It will be 2 into vapor density. And if it is 2 into vapor density, so vapor density is given here 30. So you can write here 60. So 1 plus alpha will be 92 over 60. So alpha will be, yes, you will be getting it like 32 over 60. Any doubt guys you got? Tell me. Any doubt or anything you want to ask? No doubt. Now let's move to the next problem. Yes, do it now. But before doing it, again you have to solve some more problems. Like, you know the Dalton's law. And what is the Dalton law? What is the Dalton law? So Dalton law says, let me tell you, if there are gases A, B and C. So if there are three gases, you have A, B and C. So these are moles of A, moles of B and moles of C. And when we have moles of A as well as B as well as C, what will happen? What will happen in that case? Moles of A, moles of B and moles of C. So total pressure is B total. So what is partial pressure of A? It will be mole fraction of A into B total. What is partial pressure of B? It will be mole fraction of B into B total. What is partial pressure of C? So partial pressure of C will be mole fraction of C into B total. So mole fraction you can calculate, and how you can calculate moles of A over mole total, right? Moles of A and mole total. Please ask me if you have any doubt. No doubts? So if you have solved it guys, now partial pressure you know, mole fraction you know, how to calculate that mole fraction. So after knowing each and every point, now we will determine the Kb and Kc. How will you determine that? So just note it down. Calculation of Kb and Kc. So how will you do it? So there is not a single formula which you can apply and solve all the problems, right? So how you are going to solve it? Now I'm telling you. Suppose I'm writing PCl5 gas. I'm writing it and it is being converted into it is being converted into BCl3 gas and Cl2 gas. At T is equal to 0, suppose I am taking a mole, this is 0, this is 0, and degree of dissociation is alpha. And if degree of dissociation is alpha, it will be A minus A alpha, it will be A alpha, it will be A alpha. So once you are getting it, just divide it by total mole. So total mole will be A into 1 plus alpha. So guys, now in the container I am having three gases. Now in the container, if I discuss about it, in the container I am having three gases. One is BCl5, another is BCl3, and another one is Cl2. Okay, so if I'm having all three, so moles of it are A into A minus alpha, A alpha and A alpha. So how can we calculate Kp or Kc now? So when I want to write the expression for Kp, it will be partial pressure of chlorine, partial pressure of BCl3, partial pressure of BCl5. Okay, so when you are getting it, you will be getting Kp. So how will you calculate the partial pressure here? So just calculate the mole fraction. It will be A into 1 plus alpha, 1 plus alpha, 1 plus alpha. Getting it? A will get cancelled out and multiply it by P total. Multiplying it by P total. So here you will be getting Kb is equal to alpha over 1 plus alpha into P total. Alpha over 1 plus alpha into P total. 1 minus alpha and 1 plus alpha into P total. So P total will cancel out. 1 plus alpha will cancel out. Now you will be getting alpha square into 1 minus alpha square into P total. So this is the expression, and guys, this expression will be different for each reaction depending upon the stoichiometric coefficient. Here it was 111. If it would have been 112 or 2111, then it would have been different. Okay guys, so these expressions would be different. These expressions would be totally different. Ask me guys if you have any doubt. Ask me. No doubt. So here, what are the factors on which? So guys, I tell you that it is a function of temperature only. Kb can be changed only when temperature is changed. Why I am telling you? Why I am telling you this thing? Can anybody tell me? Kb can be changed only when temperature is changed. Sorry, Kb can be changed only when temperature is changed. So if you are changing the temperature, what will happen? Kp will change. As a result, alpha and P total will also change. So degree of dissociation will change when Kp is changed, and Kp is changed when temperature is changed. Got it? So now I'm moving to the next point. On what factors alpha will depend? So alpha, if I talk about alpha square, 1 minus alpha square, it will be Kb over B total. So guys, if you are changing the total pressure of mixture, in that case as well, alpha will change. So there are two parameters on which alpha depend. One parameter is Kp and another parameter is what? Another parameter is P total. So it can also change on changing what? Alpha can be changed on changing P total as well. Alpha can be changed on changing P total as well. Right? So why I'm saying this? Alpha can be changed. So alpha depend on two factors. Note it down. Alpha depends on P total and temperature. When? If delta Ng is not equal to 0. Why I'm saying it? Why? Because guys, let me take one more reaction here. If I'm taking 2HI gas and it is converting into H2 gas and I2 gas, P is equal to 0. If this is A, this is 0, this is 0. So what it will be? A into 1 minus A alpha, A alpha by 2, A alpha by 2. So N total will be, just add them, it will be A. Because in this reaction guys, delta Ng is 0. Delta Ng is 0. So just solve it now. And on solving, what you will be getting, just divided by A. So this is mole fraction into P total. So if you are writing Kp now, what will you get? So it will be alpha by 2 P total 1 minus alpha into P total. So it will cancel square because here the coefficient is 2. So this will cancel out and you will be getting alpha square 4 into 1 minus alpha square. So here you can say there is no expression, this expression does not contain P total. And if this expression does not contain P total, so I will say that alpha depends only on Kp or temperature, because Kp depends only on temperature. So if somebody asks you that alpha always depend on temperature, wrong. Actually, if delta Ng is non-zero, then Kp in the expression of Kp, P total will come. And if delta Ng is zero, if delta Ng is zero, and delta Ng 0 means yes, then in the expression of Kp there will be no P total. And if there is no P total, so alpha can be changed only by changing Kp, and Kp can be changed only by changing temperature. Got it, guys? Tell me if you have any doubt. Tell me, guys, if you have any doubt. No doubts? Okay. So now, similarly, you can calculate Kc. Similarly, you can calculate Kc. Suppose I am taking BCl5 gas and it is converting into PCl3 gas and Cl2 gas. At T is equal to 0, this is A, this is 0, 0. After some time, A minus A alpha, A alpha, A alpha. So just divided by V, because when you are going to write Kc, so Kc will be concentration of BCl3, Cl2 over concentration of BCl5. Okay, so Kc will be, because these are mole, A will get cancelled out, but still some A will be left. So what you will get here? Yes. Now you will be getting it. Any doubt? So once you are solving it, guys, now you know how to write the Kc expression, how to write the Kp expression, and Kp and Kc, these are function of temperature only. So they can be changed only by changing temperature. But here alpha can be changed by changing initial mole or the volume. Ultimately, I told you that alpha may or may not depend upon the temperature, as I told you. So now just solve some problems. Yes, do this one. And the first problem on your screen, guys, do it. Do it fast. Do it. So how will you solve it? So it says it dissociate by 20% at 418. Now calculate the pressure at which it dissociate by 50%. So just write down the expression for it. A, and after time t it will be A alpha and A alpha. Okay. So what will be the total moles here? Cancel it into P total. So now if you write the expression for Kp, it will be alpha square into 1 minus alpha square into P total. So guys, here alpha initially it was zero point 0.2 and P total is given. So you can determine the Kp, and now you are not changing the temperature. And if you are not changing the temperature, it means Kp is not going to change here. Kp is not going to change. And if Kb is not going to change, so first determine the Kb, just put the alpha 0.2. One by 6. If Kb is 1 by 6, now what you are doing, P total is changing, as a result alpha will change but Kp will not change. So now I will write the expression alpha 1 square into P total dash. So what is alpha 1? The new alpha is 0.5. So it will be 1 by 6, 0.25, 0.75 into P total dash. So 1 by 3. So P total dash you will be getting is 3 by 6, that is 1 by 2. So this is just mathematical part. The conceptual part was this. So alpha 1, initially the alpha 1 was 0.2. Now the alpha 2 is 0.5. So how alpha is changing? You have not changed the temperature. Because you have not changed the temperature, so the Kb I am taking the same in both the scenario. But alpha is changing here. So this is the new alpha. This was the previous alpha. Are you getting it? Yes, tell me guys. Are you getting it now? Yes, Asha. It would be best if you are following the resonance for JEE Advanced instead of going for Cengage or Arihan, because that is more systematic. Okay, that is more systematic. So Asha, yes, now do this one. The next problem on your screen, do it. Do it. Do it fast. An equilibrium pressure of 480 and 204 dissociates 15% into NO2 at the same temperature. So when it says at the same temperature, it means Kb is not going to change. So what will be the equilibrium pressure required for 25% dissociation? Yes, Asha Rani, that is enough. That is enough and that is good. Now solve it guys, be fast. Be fast. Chemical equilibrium, if you have followed all my lectures, then surely you will be able to solve all the problems. I have told you all the tricks and the ways how you can solve the problem related to chemical equilibrium. Right? So N2O4 will dissociate and it will give you 2NO2. Sorry for that. T is equal to 0. A mole and 0 mole. And after some time, what will happen? It will be 2A alpha. So total mole will be and multiplied by P total. So Kb will be 2 alpha upon 1 plus alpha square into P total square. 1 minus alpha over 1 plus alpha into P total. So this will cancel out. And expression for Kb will be 4 alpha square 1 minus alpha square into P total. Okay guys. Yes, you should follow only one reference book or reference material. So don't do all the materials. That if you are doing it, that will just simply wastage of your time. So avoid doing that and focus only on one material. And lecture notes, if you are following my lecture notes on the YouTube, those are more than enough. After following those lectures, you can solve anything. So here alpha is 0.15. No, you don't need any other book. So Kb you can calculate 4 into 0.15 square and 1 minus 0.15 square into what is B total? 480. So once you know the Kp, now they are saying that alpha is changing, and if alpha is changing, then P total will also change. In such a way, their product will remain same. So again, you can write Kp, that is 4 into 0.15 square into 4. Yes, it is Kp guys, and this is equal to 4 alpha 1 square 1 minus alpha 1 square into P total dash. So alpha 1 is given. Now alpha 1 is given as 0.25. Just put the value 0.25 here. Put the value. You will be getting P total, that will be D. Delhi. So again, it was a very simple problem, but conceptual problem. Simple but conceptual. Okay. Yes, let's move to the next problem now. Do this one. It's a simple problem, and the similar problem I have already taken. Yes, after mole concept driven, you can start states of matter, the gaseous state. And after that, you should go for the periodic table, then chemical bonding, and after that, you can start physical, because once you have done the chemical bonding, then you will be able to understand each and every point. Yes, Trivin. I hope now your query is resolved. Now solve this one. Guys, be fast. Calculate the degree of dissociation of N2O4 and vapor density is given. So at T is equal to 0, this is A, this is this. A minus A alpha to A alpha. Right? So N total will be A into 1 plus alpha. Now vapor density, you know that vapor density is M average by 2. So M average you can calculate 2 into vapor density. Right? So what is the formula for M average here? M average will be weight total over N total. So total moles are A into 1 plus alpha. And how many moles of A are there, guys? What is the total weight? A into, it was 92, because I have taken A mole. Initially in my container only N2O4 was present, but once equilibrium was achieved, N2O4 and NO2, two gases were present. A will get cancelled out. So from here, M average is 2 into this. A will cancel out. So 1 plus alpha will be equal to 92 over 2 into 36 point. So from here you can determine the value of alpha. Yes, tell me now. Any doubt? Yes guys, any doubt? Yes Asha, if you are in class 11 then try to cover your 11th and 12th syllabus because KVPY will be having the complete syllabus, right? So first try to cover your basic syllabus of 11th and 12th. Basic means for IIT, and then you will be able to solve it, right? Now let's move to the next point. Do this one. Do it. It's a very simple problem. You guys can easily do it. Do it fast. You are given N2 gas, 3H2 giving you 2NH3. Equilibrium constant is K. Yes. Now, for this reaction, this is K. Now they have reversed the reaction. Okay, Gayatri Raju, thanks for your compliment. Are you regularly following those lectures? So here you are given like N2 gas, 3H2 gas, giving you 2NH3 gas, right? So the expression constant is K. Once you reverse it, K dash will be equal to 1 by K. Now instead of 2 it says here you should write 4. So multiply it by 2. So it will become 1 by K square or K raised to the power minus 2. Right? So if you are getting it, so it will be K raised to the power minus 2. C will be your answer. Yes, Gayatri Raju, solve these problems. Solve these problems. These are very good problems. Okay, you are in which class? So let's do this one now. It's very interesting problem and a little bit moderate, not tough. Yes. Let's see who can solve it. Let's see guys who can solve it. Okay, Gayatri. Do it now. At a given temperature, degree of dissociation of HI is 0.2. Calculate number of moles of each substance if 2 moles of each H2 and I2 are added in 10 liter and at the same temperature. Okay, Gayatri, if you are in 11, then we have covered so many topics of 11. You can watch recorded lectures. Yes. And whenever you get time and you come on the live class, then you can ask your queries because number of students are less. So this is advantageous for you, right? So guys, do it now. And given temperature, degree of dissociation of HI is 0.2. So calculate the number of moles of each substance if 2 mole of each H2 and I2 are added in 10-liter container at the same temperature. So how will you get it? So just write down. Okay, Gayatri, just write down H2 gas and I2 gas. At T is equal to 0, if you are getting A 0 0, A into 1 minus alpha, it will be A alpha by 2, A alpha by 2. So guys, for this reaction delta Mg is 0, it means Kb will be equal to Kc. So whether you find out Kb or Kc, value will be same. Their magnitude will be same. Yes, others, I am providing you the complete material. Bansar class is complete material. Even this year, two of my students got rank under 100 and one was Manthan Dalmia, Ronak Dalmia. So I'm providing the same content over there. We will have DPPs, modules, everything on the update section. You can download that. Okay, others. Yes, so now if you are dividing it by volume, everything will be cancelled out and you will be getting like alpha square, right? Okay, others. If you are on the plus, you can download the material from there. So here it says that alpha is 0.2. So it will be 1 by 96. No, no, just a minute. I have done some error here. And it will be 1 minus 0.2, 0.8, 0.64. So it will be 1 by 64. So Kc I am getting. Now it says calculate number of mole of each substance if 2 moles of H2 and I2 are added in 10 liter. Now I know the value of K equilibrium. Now I know the value of K equilibrium. So the K equilibrium will be equal to Kc 1 by 64 at T is equal to 0. This time if I am taking 2 moles of it and 0 mole of it, so it will be 2 minus x divided by 10. So 1 by 64 I will be writing 2 minus x by 10, 2 minus x by 10 and 2x by 10 square, because here the coefficient is 2, right? Once you are squaring it, so you can easily get 10 will get cancelled out. So you will be getting 1 by 8. So it will be x 8 minus 4x. 5x will be 8. X will be 8 by 5. Got it, guys? Yes. X will be 8 by 5. Any doubt? Any doubt, guys? And now you can calculate each and everything. So this was really a very good problem. I don't know how many of you have solved it, but it was really a very good problem, right? So now let's move to the next problem, guys. Solve it. Simple problem, you can do it. It should not take much time. Do it, guys. Yes, tell me. Be fast. So you are having a gas having molar mass 100, decomposes into 2y. So X gas, it decomposes into 2y gas. And T is equal to 0 if A moles of it were present. After some time it will be A minus A alpha, 2A alpha. And now it says Weber density and total pressure. So Weber density is given and P total is given. So total mole will be into P total. So what will be the expression for Kb here? So Kb you will write as partial pressure of Y square over partial pressure of Y. So A will get cancelled out, 2 alpha into P total is, and it will be A will get cancelled out into P total. Are you getting it? And if you are getting it guys, so Kb will be equal to 4 alpha square 1 minus alpha square into P total. So vapor density you are given, just leave it now. Total pressure you are given, calculate the Kp. So guys, how will you calculate the Kp? Now in this container I am having X and Y. So if I somehow calculate the alpha, then we can do it. So PV is equal to nRT, and if P total is there, so N total I have to take. So what is the N total? N total will be, yes, N total will be A into 1 plus alpha and 0.821. And what is temperature guys here? So temperature is not given. P total into volume is also not given. P total is given to, P total is given to alpha you can determine. So alpha how you can determine? A into X, molar mass of X, over A into 1 plus alpha. So molar mass of X was 100, 1 plus alpha. So now M average is 2 into 37.5. So guys, from here you can determine alpha and put alpha here. Temperature is not given. Okay, now you don't need it. Okay, just a minute. Here I need P total. So the P total is 218. If somehow I calculate the alpha, I can determine the value of Kp. So how can I determine that? Hi Shaikh Afreed, I'm fine. So alpha you can determine the M average. It will be weight total upon N total. So A mole, A into 100, N total will be A plus alpha. A will get cancelled out. So what is M average here? 37.5 into 2. So from here you can calculate alpha and put the alpha here. You will be getting Kp. Hi Sita Mitala. Yes guys, are you getting my point? So it was really a very good problem. Yes, it was looking tough, but it was not tough at all. You could have easily done it. So let's do the next problem now. This is easy guys. This is easy. Do it. Yes, Sita, Sheikh, others, everybody guys, solve it. Solve it, be fast. Solve it. Do it, guys. So how will you do it? You are given SO2 gas plus half O2 giving you SO3, and then this twice of reverse. This is K1 and K2. So which of the following relationship is correct? So let me take one problem here. SO3. So just reverse it. If this is K1, it will give you guys SO2 gas plus half O2 gas, right? So once it is giving you, so K dash will be 1 by K1. Now you multiply it. Now you multiply it by 2. So K double dash will be 1 upon K1 square. And it says it is K2. So K2 will be equal to K1 minus 2. So guys, C will be your answer. Yes, C will be your answer. How many of you did solve it? Tell me now. Any doubt? Any doubt, guys? No doubts now? Okay. So now let's move ahead. So the equilibrium constant Kp is given at this temperature. So you are given the Kp. If 1 mole of CaCO3 is placed in 10-liter vessel, what is the weight of CO formed? Let's see. This is easy problem and each and every one of you can do it. This is very easy problem. Do it. Do it after this. I will solve it. I'm giving you 2 minutes. Be fast. You guys can easily do it. This problem is having nothing which you can't solve. Do it, guys. I'm waiting for your answers. Yes, what will you do? Just make that container. Just make it, guys. So now I'm going to start it. Kb is given. So when you are writing CaCO3 solid and it is giving you Ca solid plus CO2 gas. So Kb will be equal to partial pressure of CO2, right, guys? And Kb is given as 0.821. So now you know the partial pressure of CO2, and all this reaction is taking place in a container. Volume of this container is 10 liter and temperature is 1000 Kelvin. So you know the mole, suppose A mole A minus X, the mole of CO2 will be same as the mole of CO, right? The moles of CO2 will be same as the mole of CO2. CO. So moles PV is equal to nRT. The pressure of CO2 is 0.821. Volume is damped. Mole of CO2 0.0821 into what is temperature? 1000. So moles of CO2 you will be getting. Just cancel it out, guys. 0.1 mole. If moles of CO2 are 0.1 mole, guys, then moles of CO will also be 0.1 mole. And if moles of CO are 0.1, so 0.1 into 56, you will be getting 5.6 gram. So 5.6 gram is this. Yes. Any doubt? So your answer will be Bombay. Your answer will be Bombay. Tell me. Any doubt? So now let's do the next problem, guys. The similar problem we have already done, and now all of you can do it easily. Do it, guys. Do it fast. Vapor density of undecomposed anode N2O5, N2O4 is given as 46. Yes, how will you do it now? Be fast. So initially only N2O4 was present. Vapor density decreases too. So this is the final vapor density. Multiply it by 2 and you will be getting M average. So calculate the percentage dissociation. So this one is easy. This one is really easy. So you will start it like this. Why this data is given? Actually, this data is given just to tell you that initially only N2O4 gas was present, and except N2O4, nothing was present. Only to tell you this data is given, and there is no other role of this data. Okay, guys. So at t is equal to 0, if you are taking it a 0, after some time it will be 2a alpha. So what will be the total moles here? What will be the total moles? A into 1 plus alpha. So M average, it will be 2 into vapor density. So 2 into vapor density is 24.5, right? Hello, study materials. Why your name is study material? Okay, I want CSC branch in bits planning. You have to work really hard. For tips, we can take a separate session, right? So first, let's do these problems which I'm helping you guys. I think these problems are most important problems and they are really going to help you in getting CS in bits Pilani or IIT Mumbai or Delhi, right? So here, initially a mole of it were present, a into 92. Now a into 1 plus alpha. A will get cancelled out and 1 plus alpha you will be getting 92 over 49. So alpha will be, you will be getting it Yes, study material. If you focus and you study for next 6 7 months, then definitely you can get it. There are many students every year. Yes, many of my students have already achieved this. So nothing is impossible. Just be focused, stay focused, and do honestly your work. And be honest with you. So what will be the answer, guys, here? What will be the answer here? 43 by 49 minus 1. So it will be 87. Yes, it depends. It depends till today, whatever you have done and how much you have prepared yourself. It depends on all those things. So it's very difficult for me to comment over it, but everything is possible. But everything is possible. Okay, guys. So now just do it. Again, a simple problem. Very simple problem. You can easily do it. Do it fast. Tell me, guys, what will be the answer? Okay, definitely I will take a session. Don't worry. Surely I will be taking a session over it. Okay, surely I will be taking. So now solve it. So how will you do it, guys? You just have to write PCl5 gas, PCl3 gas, Cl2 gas. T is equal to 0. 25% is dissociated, so A mole, and after some time it will be into B total. Right? So what will you get? Okay, Osho. That's great if you got 70 out of 70. So definitely I will take a session on bits. Definitely, guys. Now do it. So again, total pressure is 50 and alpha is 0.25. So here you will be getting Kp. And now, guys, you are not changing the temperature at all. Yes, all classes are running in online mode only. Now there is no offline class all across the world. Yes, only PDFs are provided. Video lectures are also given. No, no, no. Lectures are there. So now degree of dissociation is 50%. So you can again write alpha 1 square 1 minus alpha 1 square into P total. So this alpha 1 is 0.5 into P total. So I think now only P total is left. If you equate these expressions, this and this, so you will be getting new P total. Yes, Asha, there are definitely enough problems. I have seen that material. Even I am having that material. So don't worry about it. You just practice from it. Just practice from it. Surely it will help you. Right? So guys, this is all for today, guys. This is all for today. So in the next class I will be starting Lee Chetlier's principle. So guys, it's very important, and almost whenever a problem is being asked, Lee Chetlier is involved. Even for ionic equilibrium, Lee Chetlier is very important. So don't miss the next lesson, guys. Don't miss. Yes, for IIT, for bit set, everything problems are there. But for bit set, you also have to prepare for some English and aptitude as well. Yes, because they guys generally ask this thing. So guys, in the next class, I will be covering Lee Chetlier's principle. And Lee Chetlier's principle is very important, not just from IIT point of view, but for any exam you are going to take. Okay, so don't miss that. And Lee Chetlier principle will be covered in the next class, and I will be taking problems over it. And guys, if you really like today's class, then please share it and like it so that your other friends can also utilize it. And just click on the bell icon so that you can get latest notification of our lectures, guys. We are there on the Telegram app, and our channel name is JEE underscore English. And link for that channel is given in the description part of this video. So guys, there are some simple steps how you can subscribe to it. Now the step number one, just go to Play Store or App Store, download Unacademy's learning app. Once you have downloaded it, hit the install button, and after hitting it, you will be reaching onto this page. So on this page, click on the plus and check IIT JEE box. Once you are checking the IIT JEE box, guys, again hit the subscription button, and then comes the tricky point, guys. So for 1 year you have to pay 38,000. For 2 year you have to pay 56,000. But if you are applying my code, guys, Rahul can remember it, then instead of 38 you have to pay 34,000, and instead of 56 you have to pay 50,000 rupees. So guys, remember this code. This is Rahul game, my code. Remember it. And if you are applying it, you have to pay 34 and 50,000 respectively for 1 year and 2 year. And guys, what are the advantages which you are going to get? Yes, the course would be purely structured. Every fourth class would be doubt clearing session. And along with doubt clearing session, let me tell you one more thing. You will have live quizzes, and after completion of every topic, you will have mega quizzes as well. You will have access to the test series. Yes, that is conducted by Unacademy, guys. And test series is very important part of any preparation, because using the test series, you people will get to know about your standing, where your preparation, how your preparation is going on, and where do you stand. Okay, guys. Yes, social, logical reasoning, and all those things are asked in bits. So thank you, guys. Thank you for today. And I will again meet you tomorrow in the surface chemistry. Bye bye, guys. Take care of you.